Hi, everybody. Today we're on Unit 8, Lesson 3, and we're going to be graphing trig functions. So basically, throughout the year, we have studied numerous types of functions. Today, we're going to be graphing the trig functions. And even though you studied these trig functions in depth last year, we're going to start at the very beginning. So before I even begin, you have a link. You have a link in your lesson here, but it doesn't work on Notability. So I'm just going to hop onto that link for just a moment. Okay. So what we want to do is we want to understand the fact that a sine wave, when we make a curve of a sine or a cosine curve, okay, we're really taking a point on the unit circle and unwrapping it. And instead of going in a circular motion, we're going in a forward motion on the XY axis. And again, once again, I'll kind of show you that. Opening up the curve, and you notice it's going up and down according to what the sine function or the sine value is on our unit circle. So let's kind of talk about this and how it relates to helping us graph that function. We know when we're dealing with our unit circle, and I'm going to probably draw a very bad one. We have a radius of unit 1. We have our quadrants, 0, pi over 2, pi, 3 pi over 2, right? Our quadrant angles that break up our quadrant 1, quadrant 2, quadrant 3, quadrant 4. And we also know that each point on this unit circle corresponds to the cosine and sine value of that particular angle. So our sine, again, kind of goes from 0 to 90 degrees. Our sine value goes from 0 to 1. Then it goes from 1 back down to 0. Then 0 to -1. And -1 to 0. And it's just going to keep doing this, okay, over and over and over again. So if we fill out our table of values for our basic sine curve, at 0, the sine is 0. At pi over 2, the sine is 1. At pi, we're back down to 0. At 3 pi over 2, -1, and back to 0. What this means, 0, opening up to 1, back down to 0, down to -1, and continuing on and on and on in either direction. So these are our key points on our graph. And just to go a little bit further, we know now that we have quadrant 1, quadrant 2, quadrant 3, quadrant 4. And that pattern is going to continue. So we'd have quadrant 1, quadrant 2, quadrant 3, quadrant 4. Because a lot of times people don't understand that it's just a continuous pattern and it's repeating itself over and over and over again. Okay, so a little bit of stuff about the sine curve that we should just remember. The domain is all reals. Our range, our curve is going to go back and forth between 1 and -1. The period, or the number of times to complete one cycle, is 2 pi. And what we want to remember is our curve just keeps repeating. And pretty much this is the big stuff. Okay. And again, this year is about retaining for when we need to use stuff next year. The cosine curve, again, we think of that unit circle. But this time, 1, 0, 0, 1, -1, 0, 0, -1. We're going to use the x value, right? We're going to use the x value to help us draw the curve. Cosine corresponds to the x. So at 0, the cosine is 1. At pi over 2, it's 0. At pi, it's -1. At 3 pi over 2, it's 0. And at 2 pi, it's back up at 1. So we have our points 1, 0, -1, 0, 1. And our curve, again, repeats. And our curve is broken up into basically our intervals, right? Our quadrants there. And again, this is a forward function. So what's important is instead of a circular thing that keeps going round and round and round in this direction, we're opening it up. So now we can call it a function. We can study it as a function. It passes the vertical line test. That's very, very important, especially as you move to higher levels of math. Couple little bits and pieces of information that are also important about this curve. The domain is all reals. The range, again, our curve is going to bounce back and forth between -1 to 1. Our period, how long it takes, our period or how long it takes to complete one full cycle is 2 pi. And this curve also keeps repeating itself. Now our tangent function, and we're not going to really worry too much about the tangent function. I just like to show the graph just so you guys have a sense of what goes on and how we got it. So we know our tangent function is the tan is sine over cosine. And I could draw maybe a little mini unit circle here to help us. 1, 0, 0, 1, -1, 0, 0, -1. So the tangent of 0 would be sine over cosine, 0 over 1, which is 0. The sine of pi over 2, I'm sorry, the tangent of pi over 2 is 1 over 0, sine over cosine, which is not defined. That's why we see this asymptote when we're graphing this function. The tangent of pi, sine over cosine, 0 over -1, back to 0. The tangent of 3 pi over 2, -1 over 0, not defined. Again, this is where we're going to see asymptotes. And the tangent of 2 pi, 0 over 1, we sort of completed our kind of circular on the unit circle motion, is 0. So what's different about this graph is we have these undefined places, we have these asymptotes, okay? So if you wanted to kind of, we have the graph in front of us, but if you want to think about it, you'd need to fill in some extra points. If we go between 0 and 90 and take, like, let's say the tangent of 45, well, that would be 1. And if you remember what we said about the previous graph, this is really quadrant 4. So we know that the tangent of -45 is going to be -1. And that's how, basically, in a very, very condensed form, that's how we got the graph of the basic tangent function. Now, I'm not going to be making you really graph these. So it's just my main goal here is to make you guys, realize that the domain, we're going to have issues. And the domain, x can't be odd multiples of pi over 2. And that's really all you need to know. Why? Because we're seeing asymptotes, right? The graph is undefined at these values. Our range, on the other hand, instead of bouncing back and forth, our range is all reals. And now our period, or how long it takes to complete one cycle, is a lot shorter. You notice I go from -pi over 2 to pi over 2. So I'm completing a circle. I'm completing a cycle in pi units. And this graph, we also realize, is going to repeat itself every pi units. Okay, so just if you have a basic awareness of that, that's really all you need to know this year, and really in a calculus setting. Okay, you're totally 100%, knowledgeable about all the things you would need to know. So today, now that we have a basic understanding of each trig function and how to graph it, we're going to take a look at graphing some trig functions with basic transformation. And we're going to focus on what we consider our sinusoidal curves. And that means these situations, okay, our sine and our cosine. And before we even go any further, it's kind of important to mention, if we look at our sine curve and our cosine curve, maybe I'll try to graph one. That's our sine curve kind of superimposed. You should recall from last year, the sine and the cosines are really just horizontal shifts of each other. So that's a nice little thing just to remember. So we're going to focus on the graphs of these functions, some vocabulary and some things you should remember from last year. When we have y equals a cosine bx plus c plus or minus d, or y equals a sine of x bx plus or minus c plus or minus d, okay, these a's, these b's, these c's, these d's, they are all what we call transformations to the parent function. And we should recall from our transformation unit that we could stretch things, we can slide things, we can reflect things, and all of these numbers are going to have an effect on the basic graph. So our amplitude, or our a value, right? We take the absolute value a, is the height. So the number out in front tells us how high and low the curve goes, the maximum and the minimum values, so to speak. Our period is 2 pi over b. That's a formula you should also remember from last year. And that's how long it takes to complete one full cycle. In our basic function, when b is 1, we complete the cycle in 2 pi. When we change that b value, we change how long it takes, right? We stretch it, or we can, smush it together. And that b value is our frequency. It tells us how many curves we see by 2 pi. Horizontal shifts are anything connected in here. And what I'm going to say to you about this year, we're not going to focus on them. You studied some basic horizontal shifts in Algebra 2 trig. However, they're a little confusing, and anything you need to do in the future, you're usually going to do on the calculator. So I would not make you do those by hand. Our vertical shifts, up and down. Okay, you may see one of these, because really it's just taking your x-axis, or what you considered the midline last year, and then graphing from there. Okay, so that is something I may consider kind of practicing with. And we should know that that is always whatever number is outside the set of parentheses. And lastly, something I definitely want you to be able to recognize is if we have a negative out in front, well, that's going to flip our graph. Okay, so we have to consider that when we're graphing. Now, when we graph by hand, what I usually do is I usually tell my students that we're going to kind of visualize our basic curve we're graphing. So our curve here that we're actually graphing is a transformation of the original sine curve. And when we're dealing with our x and y axis, my x-axis is already labeled. Want to be careful here. Usually we like to go 2 units per box on the graphing paper that I'm going to give you, and it just corresponds to a proper a proper breakdown to the XY axis. Let me just show you what I mean. If we break up and let 3 boxes, okay, so I mean, well, this is every 30 degrees. So if I kind of think in terms of numbers and I let 2 boxes equal 1 unit, then this is really 1, this is 2, this is 3. Now, do you see how pi, which is 3.14, becomes 3? So that's why that means this is 4, this is 5, and 2 pi is 6. Okay, so that's why we use this. That's why I use this breakdown, because it corresponds to the number values of the pi that you're graphing. I'm going to get rid of that so as not to confuse us while we're graphing. So basically, we're going to focus on our basic function. I'm going to put it on this picture. Our sine curve usually goes 0, a pi over 2 on 1, a pi back to 0. So here's our basic sine curve. And what we're going to do is our transformation now, 2 sine of 4x. So my amplitude is 2. So that means, okay, if I'm focusing on my points here, my big points in the graph, these are what's important. When I'm at the highest point on the graph, instead of being at 1, it's going to go up to 2. My zeros will stay the same. My lowest point will now go down to -2. We're going to stretch. Let's see how else my transformations will affect my graph. My period is 2 pi over b. So 2 pi over 4 equals pi over 2. That means instead of seeing one cycle, right, instead of completing one cycle in 2 pi, I'm going to be done with one cycle at pi over 2. We're smushing this graph together. So we're going to finish one cycle by pi over 2. And our frequency is our b value, or 4. What does this mean? I'm going to see 4 curves by 2 pi. So how are we going to go about doing this? Without getting too technical or crazy. Think about, right, always going to follow the same pattern there. So we're going to focus on those 5 key points in our graph. When I graph this, my zeros, I did nothing to affect my zeros. So, well, I did a little bit. I'm going to start at 0. I'm going to stop. So this last one over here, I'm taking this and I'm smushing this whole curve. My end is going to be there. I'm smushing this down. So now I have to worry about my middle 0. My middle 0 is going to go halfway in between. I go up, down, down, up. So I'm going to go up, down, up. So this guy here is going to be the up part. Go halfway in between. Now, instead of going to 1, my graph is going to go all the way up to 2. I'm going to go halfway in between my next 2, right? And I'm down at my lowest point. So I go here, go halfway in between, and go down to the lowest point on the curve. Oops, I missed my 0. Who cares? Basically, the idea, I just want you guys to understand numbers change what the picture look like, and you should have a sense of what those changes are. That's why I'm making you graph by hand. This is just going to keep repeating. So another pi over 2, I'm going to see another curve. Up, down, up. Oh, I didn't do as good this time, but halfway in between. Up, down, up. Connect the dots. One more time. last curve, halfway in between, up, down, down, up. And I could expect something of that nature. I could expect you guys to handle something of that nature. Now, if you want to check your work, by all means, and I think Desmos does a nice job. Two, oops, 2 sine 4x. And you can kind of see, I don't think I can, yeah, I can't draw on it, so I can't, but you can kind of see there. You have the XY axis, you can get an idea of if you graphed correctly. Okay. I think we're going to try one more together, and then I think we will be done with today. Now, this one's going to be a little bit different. Okay. In this graph, we want to, I'll do the basic one. I'll do the basic cosine function in my pink color. 1, 2, -1, -2. Cosine starts at 1, 0, -1, back to 0, back up to 1. Down, down, up, up. That's the basic cosine curve. Now we want to look at our function and how we changed it and how that's affecting us. This time my amplitude, which is the absolute value of A, is again 2. So it means my highest and lowest points are going to be 2 and -2. I see this negative out front, so I know I'm going to be flipping my curve. My period is 2 pi over 2, which is the same as, if you flip that up, 2 pi times 2 over pi, which is 4. Now this is weird because I don't have a 4 on my graph, but we have to remember what I talked about in the beginning of the period, that 1, 2, every 2 boxes, one, two, sorry, made a mistake there. Every 2 boxes is 1 unit. So see how I can graph numbers and angles on the same XY axis. And our frequency is B, which is pi over 2. So we're going to complete one curve by 4. And we're going to see, well, what is pi over 2? That's 3.14 divided by 2. We're going to see 1.5 curves by pi over 2, or 1.5. I'm sorry. We're going to see 1.5 curves by 2 pi. Let's try to put all this together. Remember, we're focusing on the key points that are in the graph to begin with. So my original function, the highest point right now, I start at 1. I'm now going to be at 2, but I'm going to reflect it over the x-axis. So my first point is going to be at -2. My curve, right? I start at 0 and I end at 4. So wherever I start with the cosine function, right? I'm going to go to the end. This last point, I'm going to stop. I'm going to put that point at 4. Halfway in between my start and my stop point, halfway in between there, I'm at my lowest value. But what I have to remember, I'm flipping this curve. So halfway in between, 0 and 4. Instead of being my lowest value, I flipped this curve up and I'm at my highest value. Halfway in between my highest and lowest number is my x-intercept. So my x-intercept here is going to be at 1. Halfway in between my highest and lowest value. And go halfway and there. There's one curve by 4 units. I'm going to repeat the process. However, since I'm only graphing to 2 pi, I'm not going to be seeing as much as the curve. So I'm going to be back up at my highest point at 2 pi. So halfway in between is my 0. And again, we see 1.5 curves by 2 pi. So this is a little bit of a weird way to graph, okay, but it's just to get you guys seeing the repetitiveness of it and how everything connects together. Again, if you're a little bit confused, if you're not sure you did your work right, go right over to Desmos or whatever you want to use. So -2, this is cosine, pi over 2x, so pi divided by 2x. And you should see your curve bounce right on the screen. If you kind of look closely, you can kind of see from 0 to 6, it matches what we have on our paper. And that's it for today. In this lesson, I did include a little recap of some of the basic functions that we talked about. In addition to that, some of the reciprocal functions that you may discuss in future years. We're not going to concern ourselves with them this year, but it's just good to know that they exist. For instance, the cosecant is the reciprocal of the sine function. The secant is the reciprocal of the cosine function. Again, I'm not going to expect you to really know anything about these other than that they make weird pictures with asymptotes. Okay, that's really all you need to know, and that you can graph them. And if you see them in the future, that's, that is just depends on what levels of math you take. All right, thanks everybody. Have a good day.